there's a lot of work being done with this thing called machine learning and deep learning. And on the livestock and rangeland management, that has to do with creating an automated system of counting livestock. And in some instances, some research is being done to estimate size, estimate weight, identify injuries, things like this.
In this episode of Voices from the Field, NCAT Sustainable Agriculture Specialist Colin Mitchell talks with Matthew Kutugata about using drones in agriculture. Before Matthew started pursuing his Ph.D. in agronomy from Texas A&M, he worked with Colin and the rest of NCAT's Southwest Regional Office team on the Subtropical Soil Health Initiative as a graduate researcher at the University of Texas at Rio Grande Valley. Much of Matthew's research has been driven by data gathered by drones. He and Colin discussed different applications of drones in agriculture, including monitoring and scouting operations, the utilization of multispectral cameras to monitor cover crops, and other aspects of Matthew's research. Let's listen.
Hi all, my name is Colin Mitchell and I'm a Sustainable Agriculture Specialist out of NCAT's Southwest office based in San Antonio, Texas. And today we are joined by Matthew Kutugata to discuss the use of unmanned aircraft systems, commonly known as drones. And we're going to be talking about the use of drones in agriculture. Matt is currently pursuing his PhD at Texas A&M in agronomy. I got to know Matt while he was pursuing his master's at the University of Texas at Rio Grande Valley when he was part of Dr. Alex Rosellis' agroecology lab. While at UT Rio Grande Valley, Matt contributed to our Subtropical Soil Health Initiative, which is funded by USDA and RCS through the Conservation Innovation Grant Program. The Subtropical Soil Health Initiative focuses on research and education around cover crops and other methods in row crop farming systems to improve soil health in subtropical semi-arid regions. The lion's share of our work takes place in the lower Rio Grande Valley near the U.S.-Mexico border. So Matt, thanks for joining us today.
Yeah, thanks for having me, Colin.
Yeah, happy to talk to you again. I haven't seen you in quite a while since I think you took off to College Station.
Yeah, it has been a while. And so glad to be able to catch up.
Yeah, me too. So let's go ahead and dive into the questions. What led you to a career in agriculture, and how did you end up deciding to focus on the utilization of drones to monitor crops?
Yeah, so I did my undergrad at UT in Austin, and I think we were there at the same time. We probably overlapped somehow.
We were, yeah.
Yeah. But I did my undergrad in geography, did some work in GIS, so Geographic Information Systems. And after that, after undergrad, I worked in parks, farms, nature centers, was always sort of outdoors. Had worked with some organizations that were implementing sort of conservation agriculture techniques like cover cropping. And so that's sort of how I got into agriculture. It was sort of more not your typical route in some ways, but while I was working for some of these organizations and in a lot of ways working to implement these techniques, I was doing a lot of reading and sort of became more and more curious as to how to get them to work effectively and get them to work in a way that reduces costs, but also improves our soil health and all these things. I got into drones. So after I'd been working after undergrad for some years, I decided I wanted to go back to school. Through a mutual friend, I had come in contact with Dr. Rosellis. Knew that he had an agroecology program. It was in the Valley, which is, I spent a lot of time growing up in the Valley, was born in Harlingen. So that really worked out. And there was an opportunity in his lab to work with drones. And I wasn't necessarily interested so much in drones as I was in sort of the technology itself, the sensing and the image analysis part. That I just sort of previous to that, started working on programming, sort of teaching myself how to do some programming. So yeah, there's an opportunity there, and I just sort of took it, and so that was exciting.
So you mentioned, the imaging and those aspects rather than being interested in just the drone itself and going out and playing with a cool toy. What are some ways that drones can be used in crop and soil management?
The drones are really a way to collect a lot of images of a large amount of area. You sort of can look at it in two ways. There's the consumer sort of side, and then there's sort of the research side, and they're really actually connected in a lot of ways. So first, sort of the way that I look at it on the consumer side is, farmers, uh, land managers, conservationists can use sort of over-the-counter drones, ranging, there are all sorts of companies, and they have drones ranging from, thousand to several thousands of dollars. And these can be used to use for scouting, right? I mean, you think about a land manager or a farmer, they drive around their field, and really they're able to sort of inspect, monitor for pests, nutrient deficiencies, these types of things, but really only looking at the perimeter of their field. And so a drone, is really, I think, easy way to get a full field view of what's going on, especially in the interior. So then you sort of open up this, door of possibility of looking at, well, now you can look at the whole field. And on the consumer side, it's really, you're able to identify things that you can see with your own eye. There's really no, the image analysis part on the consumer side becomes a little tricky. But so you're using a drone. Farmers can use drones to identify low-lying areas within their field, nutrient deficiencies, pest damage, you name it, right? I mean, it's really just a bird's eye view. That's the main advantage there that you can use it for. But then I also mentioned sort of the research side. And so one component of the research side is, well, then being able to quantify what the consumer side is saying. Okay, so we're able to put a number on nutrient deficiencies, or on maybe certain types of pest damage. This is sort of known. This is phenotyping. So being able to observe characteristics of plants and growing systems, and being able to quantify those observations to then be able to perform some empirical analysis, saying, okay, for sure there's a significant difference between this crop variety versus this crop variety, or this cover crop and producing a certain amount of biomass versus this cover crop, and so on and so forth. So on the research side, it's you start stepping into the image analysis part and the more analytical part, and that has to do with a number of different softwares, implementing different sensors, and that can get a little bit tricky. And so that's what sort of my research was about.
So we touched, just very briefly on crop and soil management. We'll get further into your research here in a minute. What kind of applications would a livestock or a producer or rangeland manager use drones for?
Being totally honest, I don't do a whole lot of work in rangeland, or sort of livestock management, but I would imagine that drones would be really useful for, again, sort of doing similar things, right? To being able to cover a large amount of land, to be able to scout, count more or less, get a pretty good idea of where livestock are. There are also thermal imaging systems. So this is, again, something that I have not had any experience with, but I've just read about. And so there's a lot of work being done in using thermal imaging systems, and just to get a better idea of where livestock are. Livestock can sort of blend into the land if you're way high up and looking at a lot of land. So counting those livestock or getting an idea of where all those animals are at can be difficult. But with the thermal sensor, you're just picking up heat. that's radiating off of bodies. And so I imagine it would be a little bit easier to find, lost or misplaced livestock. Getting deeper into things on the research side, there's a lot of work being done with this thing called machine learning and deep learning. And on the livestock and rangeland management, that has to do with creating an automated system of counting livestock. And in some instances, some research is being done to estimate size, estimate weight, identify injuries, things like this. So monitoring behavior. And this is all being done, through drones, but also through sort of just any sort of camera being held in place.
Yeah, I imagine when they're looking to technology as well. I could see with, when they have tags and being able to identify those and be able to correlate those with something like a pasture map or something like that, which is like a grazing management, amp grazing software. It's very cool. So while you were at UTRGV and working with us on the Subtropical Soil Health Initiative, our work mainly focused on trying to figure out, the best species of cover crops, planting rates, planting dates, and termination methods for dryland farming systems. We did some in vegetables as well that were irrigated through furrow irrigation, some drip tape. How did your research with drones and, I guess, remote sensing play into these project goals?
Yeah, so we looked at, when we're studying cover crops, we look at a number of different factors and we try to, again, like quantify those. So we're taking lots of different types of measurements to get like a well-rounded idea of how the cover crop, how successful this cover crop is for our system, for our area. So one of those is canopy cover, right? And this is sort of a measure of how the leaves are covering the ground, and that sort of has to do with keeping moisture in to the soil, keeping the soil cool, shading out weeds, and also providing biomass to so that you can add more organic matter, which can decompose, add nutrients. So my research had to do with quantifying, being able to look at the amount of canopy cover for different types of cover crops that we're using. And this was in multiple acres. I believe it was around 7 to 12 acres, something like that. So sort of large scale. And usually, when you're looking at canopy cover, this is a pretty common metric that you're using to sort of evaluate crops. Usually what you do is you go in, you put a quadrat, so this meter by meter or half meter by meter, half meter square on the ground, and you try to estimate. You look down on this quadrat and you estimate more or less, okay, there's 75% ground cover. And you do that, as many times as is reasonable throughout different trials or treatments. And you do that multiple times. And then you gather that data and you sort of extrapolate and you generally say, okay, based on the data we gathered, this is canopy cover. Well, the hard part about that is you're only getting a relatively small sample, right? In 7 to 12 acres, right? How many? There can be a huge amount of in-field variation, right? I mean, it really is like an agroecological system in that sense. It's just complicated. So instead, we said, well, let's use drones to go up high, get a full field view, and then using some image analysis techniques, let's try and estimate the amount of ground cover there is. And we also had a multispectral sensor. So this is different than just the regular sensors that most drones have. This is a special sensor that we had to buy separately, get hooked up, and that was sort of a whole process. So using this sensor, we took canopy coverage, and at the time we were looking at several different cover cropping strategies, from mixes to single species to legumes to large broadleafs like radishes, tillage radish. And so then we were able to use these image analysis techniques to then estimate canopy coverage, not on just the meter by meter square couple of samples, but across the entire field. So then we had really the entire picture when it comes to canopy cover. We found that, sort of what we expected, what you would think, right? Radishes had a large amount of canopy cover. But at the time, we're also experimenting with rates, the amount of rates that you would plant a certain cover crops. So like sun hemp, for example, we used at a single rate, at the recommended rate of planting, and then we used at 1.5 times the rate. So the idea being, well, if we were able to plant a little bit more, is a little bit more better, in terms of canopy coverage. You would think, oh, well, yeah, you get more seeds per acre. You get more plants per acre. That's going to help you generate more biomass, more plants per acre. Well, through our research, we found that's not necessarily true, right? I mean, so what we saw is that there was actually less canopy cover in the 1.5 acre rate than the regular recommended rate. And that really is sort of a function of overcrowding, right? So there was sometimes a desire for, this happens everywhere. Okay, if I'm just going to do a little bit more, so that's going to help me sort of keep me over and help me produce more biomass, but that's not necessarily the case. So it's really in everyone's best interest to stay by the recommended rate, so on and so forth. But in a lot of ways, like the drone, the image analysis techniques we used really just confirmed what we had seen on the ground for the other treatments. But it was also, like I said at the very beginning, it was just one metric that we used to get a whole big picture idea of the success of a cover crop. And when we looked at our other pieces of data, like soil moisture, for example, those things didn't always align with sort of what we saw from just canopy cover. So if we just looked at canopy cover, we would think, well, radishes were great. I mean, they provided a huge amount of canopy cover. They did that. That's success right there. But really, that's not the big picture, right? There's so much more that goes into evaluating cover crops than just canopy cover or biomass. Because on the soil moisture side, we saw, as you would expect, radishes required a lot of moisture, and they took that moisture for the incoming cash crop. And so that, if you're evaluating a cover crop, that's not a good thing. You want, especially in dryland farming, you want to keep that soil moisture for that next cash crop. So I think the biggest lesson there was that it's complicated, right? It is like, you've got to look at multiple factors here. And really, my research was like a methodology project. So looking at how can we use this technology to gather data more effectively and efficiently.
Yeah, that's really telling. I've spent a lot of time doing more rangeland monitoring than cover crop monitoring for ground coverage, and then we do species identification. So having a drone versus standing there on a transect when you're in a 40-acre field and you're on a 50-meter line, that's like you said, that's just a little snapshot. And so I think that drone application that's really valuable to get a more accurate picture of the variability that takes place across the landscape. I think that's really important. So you said your research was more of a methodology, and I think you alluded to what some of the findings were, that, we can't just have these kind of monolithic assessments of success for cover crop implementation, like biomass or coverage, because we have other important things like soil moisture, which is huge down in the valley and in any dryland system. Were there any other methodology efficiencies that you kind of came up with or found for monitoring cover crops?
So yeah, so down there, my work didn't have a whole lot to do with the soil moisture, but a lot of work that Stephanie was doing, which you all had talked earlier. She was doing a lot of work on understanding soil moisture. So they had implemented a sort of a system of these moisture monitors in the field, which were just taking data every 15 seconds. And those, that is really valuable data, I think, to be able to monitor, every day, but also the effect of rain events, how moisture is being, taken up by soil, how it's being retained long-term, short-term. I mean, that's some pretty valuable information there, especially when it comes to, like we said, dryland farming in, sub-arid region.
Yeah, and just a spoiler alert, we have a podcast I'll be doing with Dr. Russell soon on called "Do Cover Crops Steal Water?" So we'll be we'll be getting into that for sure. That's cool. So stay tuned if you're listening. So compared to other remote sensing options to evaluate cover crop coverage and biomass versus weed coverage, how do you using drones compare? Are there other ways to monitor cover crop success, than other than that 1 meter by 1 meter square that you do the coverage assessment on?
Yeah, cover crops, evaluating their success, that's a tough one for sure. There's a whole lot of things that go into that, and not just, agronomic metrics, but also sort of the social, cultural, economic contexts. Those all have major roles to play on influencing adoption rates for cover crop, right? I mean, there are a lot of sort of up and coming farmers who want to implement cover crops, but there are sort of, in some cases, older generations of farmers who are a little bit resistant, and understandably so, right? And so that's, you have to think about that. And there are major costs that influence whether or not someone's going to pick up cover cropping. I mean, it's in a lot of ways a risk that farmers are taking. In terms of evaluating the success, that's a tough one. That I think we know a lot about the benefits of cover crops and why they're good and why we should do them. But when it comes to implementing them on large scales and implementing them in a way that are effective and economically viable, that is still, I think, a major area of research. And really, the farmers, people in the field are sort of leading the way on this. And people in academia, scientists, we're looking at farmers, we're trying to understand how they're doing it.
Yeah, I feel like you just really highlighted what I feel like almost the ethos of this project has become, and what almost all of us that work on it, I feel like parrot that sentiment of, especially in the valley, or even the south, we don't have the killing freezes of Wisconsin, where it's easy to terminate and you can roller crimp it after it's already frozen. Yeah. When this year was an exception. There was a winter storm, but that's not the normal case. And reliable, and that farmers are taking a risk and putting themselves financially on the line to, of course, get improved things like infiltration rates, more organic matter, ideally more extreme weather resistance. But we as a society are also getting those improved ecosystem services as for water quality and carbon sequestration and climate change mitigation. So I think that's something I think it's been very revealed, that it's not just go plant cover crops. It's much more.
But in terms of like the remote sensing, just to get back to that question, when I think about remote sensing, there's sort of the drones, which are more modern sort of techniques, and then there's satellite imagery, and that prior to probably early to mid 2010s, really satellite imagery was not a viable solution for monitoring field level interactions, right? Because the resolution wasn't there, right? So you need to be able to look at plant, even leaf level resolution, and images that satellites are giving you are just, there's not enough pixels per millimeter, right? Whereas drones, we can fly much closer to field, so those images are really high resolution. I say that, but now we have more and more satellite sensing options that are higher resolution. And so when it gets to large scale, there are some satellite imaging solutions there, or maybe not solutions, but some potential But that can also get tricky because you have to go through some work to actually get those images in most cases. So those high resolution images you have to sort of apply for, and most of the times you have to buy, and they can be quite expensive. In terms of remote sensing for evaluating field level crop interactions, I think drones are really the most viable, both on the consumer and research side. And there's all sorts of caveats to that as well. When you get into the 100-acre scale, even drones can be really difficult to do. Anything beyond 20, 50 acres gets sort of complicated, even with drones.
Yeah, those size recommendations are really important because scale and the efficiency of the tool is important for people to know, because I've heard other people advocate for using it on 15,000 acre farm, but it sounds like that's not really that pragmatic.
Yeah, and that it can get complicated because then you're also talking about like a different type of drone. So there are fixed wings, and then there are rotors, sort of multi-rotor systems. And when you're talking about large scales like that, you're definitely talking about a fixed wing, because a multi-rotor system that goes up and down and sort of side, just not built for those large scale. And it's really a time issue, time and speed issue. And it's a balancing of multiple factors, from time, speed, height, how fast a camera can take images, the resolution. So yeah, there are a couple of factors that come into play.
What is kind of your drone setup, and what does that typically cost, and what kind of a scale would you say your setup is for in your research?
The drone setup that we use for my work in my master's and in my current work are pretty similar. We use multi-rotor drone. It has 6 rotors, and it's called a DJI Matrice 6000 Pro. Of the available drones, it's on the larger, heavier side, but it's also, which means that it can have a larger payload, so it can carry heavier objects. We're not carrying heavier objects, but it's also able to resist wind, changes in wind direction, and it's just more stable. So that's really important when you're taking images, especially in South Texas, right? So that's our drone setup. Now our sensor, that's always, when you're talking about research, there's the drone and there's the sensor, because a lot of times you're using a multispectral sensor. So that's RGB is what we have on our phones and most drones, red, green, blue, and multispectral is just more than 3 bands or channels. So we have RGB plus another channel called near infrared, and this near infrared channel, so this is capturing light in the light spectrum that our eyes can't see, but nonetheless it's still there. And it turns out that plants reflect a lot of this type of light, so that's really valuable information. They reflect near infrared more than any other type of light that we can see. Lots of information there. So we want to capture that portion of the light spectrum. So we use a sensor right now we're using a sensor called Red Edge M. It's from a company called MicaSense. In Dr. Rosellis's lab, we use a sensor from a company called Slant Range. There's a Slant Range 4P plus. Both are very similar. And then on the image analysis side, we use several different types of softwares. That's when I was sort of saying that it can get a little bit trickier. The learning curve is pretty steep when it comes to the image analysis side. I know for my master's, and this is, I think, the story for a lot of researchers who are getting into this, that they spend a lot of time troubleshooting, figuring out problems for, okay, why is this sensor not talking well with my drone? How can I efficiently get images from my drone, from my sensor, to my software that I'm using in the lab? And then these images have to be formatted. So there's a whole sort of process there that can get a little daunting, but eventually we get sort of the products that we want. In terms of cost, it ranges. So our setup was anywhere from about $7,000 to $10,000. Most of that cost was a sensor. right? So these sensors, these multispectral sensors, can get quite expensive. Now, I say that, but in terms, historically, they have come down in price big time, like significantly. I mean, 15 years ago, if you wanted a multispectral sensor, I mean, you're talking about tens, 20 thousands of dollars. Yeah, so now they're pretty, relatively viable compared to previous years. And then, so then you're spending $5,000-$10,000 there, plus another couple $1,000s on software. A major piece of this equation is creating it's called an orthomosaic. When you're taking images of a large field, you're moving the drone across the field in sort of a lawnmower fashion, and every second you're taking pictures. So you can imagine at a certain height, a certain field size, you're spending about 15-20 minutes taking a picture every second to every 2 seconds. You get a lot of images. So then there's a photogrammetric process of mosaicing all these images into one, so that you're looking directly down on each area. So that software can cost anywhere from $800 to $1,500, $1,500. Yes, so a number of costs involved when it comes to the analysis side, image analysis side. In terms of consumer, if really, like I mentioned, farmers can use this for scouting, monitoring, getting full field views of their crops, then really you're just purchasing a over-the-counter drone, which is all set up. I mean, it's got everything really you need. There's no messing with a separate sensor, right? Because the camera is already attached. And it's really just a click and play sort of setup.
Yeah, so it sounds like that. Yeah, not only in research, but if someone wanted to monetize that, it'd be more from an agronomic services kind of viewpoint. On the average farmer can't go drop 15 grand, or probably doesn't have time to be flying that around and figuring all that software.
For sure, yeah, and that's, I think there's there's a lot of potential in drones, and everyone sees that. And so it's really tempting to go and do just that, right? To go and all right, let's just go figure it out. But yeah, it takes a lot of time. I mean, it took me about 2 years of my master's to really figure it out. And that's because I could devote all day to that. It was really a combination of software and hardware, learning different types of software, and then physically attaching these sensors just right. Now that was in 2018, 19, and things are changing and becoming a little bit more standardized. But I think we still have a long way to go before it is really easy. So I think anyone on the sort of more image analysis side, the advice I would give is sort of be patient and expect things to go wrong, because they absolutely will. I probably shouldn't tell you the story, but one of the first things that I did is I got this sensor. It was a $5,000 sensor. It's a very expensive sensor, very powerful. I plugged it into the drone right away and I fried it. And I felt horrible. It was the worst, right? I mean, and fortunately, it wasn't fried. I thought I'd fried it. And we were able to send it back. But it could have gone way worse. We sent it back and we got it fixed. No big deal. So it's, things like that. Well, I'm not suggesting that you just go plug in any sort of sensor, right? But maybe do a better job than I did of reading instructions. There's stuff that will go wrong. It will, drones crash. And that's a pretty horrible feeling as well. I think a lot of people that I work with, they all have the story of crashing their drones. Sometimes it was within their control. A lot of times it's not. But those sort of things just happen. Fortunately, I can say that my time with Dr. Rosellas, we never crashed our drone, but I definitely had nightmares for sure.
We did have to repair it after you left, so I think I got crashed at some point after you graduated. Good to know. I'm glad you avoided that heart attack with that sensor, and that will lead me into my next question. But yeah, I have heard horror stories. I work at the videographer, and he was filming on a boat, and they moved the
Oh,
boat,
yeah.
and because you set up this program where it's going to take off and land in the same spot, and it landed into the water and just
Oh, no.
went to the bottom of the bay. So,
Yeah.
um, so speaking of that, for those folks that are going to go out and buy drones, again, they are repairable. But what are some drone flying like basics you've learned? Do you have any advice for like kind of get into it? Should they buy like a cheaper drone to like get accustomed to? Like, they make a couple $100 ones before you can buy the $1,000 DJI or
I think, like a lot of things, technology, you get what you pay for, right? I think it's a really good idea to look at what the FAA has provided in terms of educational resources, licensing. So to be clear, like myself, Steph, a couple other people on Rosellas's lab, a bunch of people on the lab that I'm working with, we're all FAA licensed under Part 107. This is the legislative term that we use, the licensing term the FAA use to designate drone pilots. And so you'll need a license anytime you're flying, anytime that you are, this is the way the FAA words it, I believe, anytime you are financially benefiting from flying a drone, right? So the distinction is between hobbyists and those that are benefiting financially. And so if you're flying over your farm, I believe that will be considered, you're benefiting financially, right? So, and even if you're not, you want to take those courses that FAA has. You want to become familiar with the restrictions, the regulations, but also like they provide a lot of information just about flying, about hardware, about weather environments, about, there's an entire world of aviation that's happening above our heads. And so if you're flying a drone, it's, I think, a good idea to sort of become at least semi-familiar with that world. And so the FAA, I think, has done like a pretty decent, and I'm not affiliated with like FAA in any way, but I think they just have like a bunch of resources there, so that would be helpful for anyone getting started. So definitely check that out. And then, like I mentioned before, just like be patient. I mean, because it's going to be hard, and you're going to get like frustrated. I mean, my lab mates know how frustrated I've gotten, and others have gotten, and it just takes time. But I think in the end, you just learn more about what's happening in your field. So it helps.
Yeah, that's a great plug for those FFA or FAA classes. Not
Yeah.
that you work for them, but it's always good to avoid, maybe a potential federal crime, or like if
Yeah.
you're, farmers near an airport. It's just it's a good thing to know those things to protect yourself.
And I'll say, like, so the FAA just also made, so you have to renew your license, and the FAA just sort of instituted this new rule where instead of having to pay like another $200 to renew your license, you can update your license by taking a course online, like a refresher course. And so that's been, I'm just like thrilled about that. And really it's just better because more people are going to do it, right? More people who are viewing it, more education that's out there, all the better.
Yeah, anytime they can lower that bar to access for like tools that are going to get just more and more useful is what we need. So we're almost at the end of our time. I did want to ask, now that you're pursuing your Ph.D. at Texas A&M, how are you building upon your, the research you did, with UT Rio Grande Valley and Subtropical Soil Health Initiative?
I'm looking at using drone imagery, continuing to do that. We just came out with a paper that uses drone imagery to estimate the amount of seeds that are coming off weeds. And we're using a pretty simple image analysis technique that uses a technique called NDVI, Normalized Difference Vegetation Index. And that's just like a simple manipulation of bands. And so, doing work there. I'm also working with Dr. Dan Martin from the USDA, who's using remotely piloted aerial spray systems. So this is like the site-specific application of herbicides. And so we're all sort of familiar with sort of the impacts of the overuse of herbicides. And so this is seen as sort of that first step of looking at how we can use drones to be a little bit more efficient with the application of those herbicides, instead of the broad spray across multiple acres. But my future research, what I'm working on now, has to do a little bit more with the image analysis side, the image side. When I first started, I was able to read a lot about all these techniques, image analysis techniques that were being used. And one of them was, I kept coming across like this technique called machine learning, deep learning. And a major component of using this very powerful technique is having large amounts of data. So in our case, it would be image data. So having a lot of examples of crops, weeds, because even within a single species of weed or a single variety of crop, you can have a huge amount of variation. And so if you want to use images to be able to detect weeds or detect stress in crops, you have to be able to essentially train a computer system to be able to identify that type of stress or that type of crop or weed. Right? So you need a large data set. And so my work has to do with developing these data sets that can be used for these image analysis techniques.
It's very cool. It sounds like you're very much on the cutting edge of using machine learning for farmers in a pragmatic way, and that's fantastic. It's good to hear.
Yeah, it's exciting field, I think, to be in. So yeah, I'm excited.
Great. Well, hey Matt, we're at the end of our time, and I just wanted to thank you again for doing this and wish you the best of luck with your Ph.D. Look forward to calling you Dr. Kutugata here in the near future. And
I appreciate it. I mean, thanks for having me on. It was good to catch up. I love listening to the podcast. It's got a lot of good stuff on there. So I'm glad y'all are doing it.
Yeah, thanks so much, Matt. And before we sign off, I did just want to take time to thank USDA and RCS, their Conservation Innovation Program, for sponsoring our project and this podcast, and also the ATTRA program. They're also part responsible for this podcast as well. And through that program, we're able to provide free technical assistance. So if you're listening, you ever in need of help on your farm or ranch or food business, give us a call. Head to our website, attra.ncat.org. So it's attra.ncat.org. And thanks for listening, and be well.
That's it for this episode. Thanks for listening. Additional information about this episode and related resources can be found at attra.ncat.org. Don't miss an episode. Subscribe to Voices from the Field wherever you get your podcasts. I'm your host, Rich Myers. ATTRA, Voices from the Field, is produced by the National Center for Appropriate Technology, headquartered in Butte, Montana. It's supported by the USDA Rural Business Cooperative Service as part of NCAT's ATTRA Sustainable Agriculture program. Any opinions, findings, conclusions, or recommendations expressed in this recording are those of the participants and do not necessarily reflect the views of the USDA or NCAT. We'll catch you again next week, and until then, keep on farming.